Hi, MaizeGator here. In this video, I'm going to show you the intended solution path for my puzzle Starmie. This is a Masyu-Star battle hybrid, and the way it works is Masyu, you have to draw a loop, and this is slightly non-standard Masyu, so in regular Masyu, you draw the loop along centers of cells, but in this Masyu, you have to draw the loop along edges of cells. The loop has to visit all dots, and it has to follow certain rules for visiting dots. So on a black dot, I have to turn on the dot, and I have to extend by at least one vertex on either side. So I like to think of black dots as large L's. On white dots, I have to go straight through the dot and then turn in at least one of the sides. So that's a valid configuration of a white dot, as is this. I can turn on both sides of a white dot if I'd like, just so long as one side is a turn. This, however, is not a valid configuration for a white dot because it is not turned on at least one side. The gray dots act as either black dots or white dots, and the solver has to deduce which. And the star battle part comes into play because the Masyu loop is going to divide the grid into regions, and I have to place exactly one star into every row, column, and region such that no two stars touch, not even diagonally. So if you'd like to have a further look at the rules or try this puzzle on your own, I'll put a link in the description below, but for now I'm going to get started. The way to get started is by noticing this black dot on the very close to the grid border. So because I have to go straight on a black dot, I can't go left or I can't go down because it would go off the grid. So this shape is forced just by the rules. And now these dots that are kind of close to it can now not be black, because if it were black, it would have to go up, and that would cause a branching of the loop, which it cannot do. So I know it's a white dot, and I know it has to go straight through like this. The white dot cannot turn on this side because that would cause a branching of the loop, so it has to turn on that side. And the exact same logic symmetrically is applying to this this gray dot, which has become a white dot. Now in this puzzle, the rules did not say this, but I think it is essential to keep track of what side is inside the loop versus which side is outside the loop. So anytime I've got a border that is on the edge of the grid, I know that that side has to be the inside. So green is going to be my color for inside the loop, and gray is going to be my color for outside the loop. And once I've established the loop inside-outsidedness for one side, I know that that is gray, this is green, that is green, and then this loop end is going to have to connect over there, so I also know that that is green. And then another slight implication of this is that all the green, this doesn't come into play yet, but it'll come into play later, all the green is going to have to connect to each other. So for example, this and that could not both be gray, but at least one of these has to be green so that the loop inside can get out and touch the rest. Now, these dots, which are now adjacent to the white dots which have turned, cannot now be white, because if they were white, it would go straight through, and then I've caused a branching of the loop right here. So that can't be true. So these have to be black dots, and there's only one possible configuration of the four possible ways that a black dot could go. And that will also allow me to shade in some more of my inside-outsidedness. Now I can look at this dot now and notice that if it were a black dot, it would have to go up like this. It would touch the white dot, so it would have to continue straight. Now this black dot could now not go left, so it would have to go right. And the problem with that is that I've now stranded this dot in the lower right-hand corner here. So there's no way this would have to be a white dot in this version of the world. If the white dot, whichever way it goes, both loop ends can now not get out is the point. So I could connect one of them like this, but then there's no way to get this loop end out without making a little mini loop. So that cannot possibly be the case. So because this dot has to be visited in some way or another, I know that this dot cannot be black because that would strand it. So I know this is a white dot. So it has to extend to go straight through, and it has to turn. So I can also fill in some of this. So there's an advanced trick that I know about white dots. So this gray dot has become a black dot. What I could do is I could shade this this white, because I know that for a white dot, it's either going to go straight through like this, in which case my grid inside-outsidedness is established like that, or it's like this, in which case my inside-outsidedness is like this. So no matter what, once I know that this cell is outside the loop, this cell is inside the loop. That's a slightly more advanced trick. I think my solution is possible to see without knowing that, but it becomes a little bit less clear to see, and I'll show you when it becomes relevant. So this white dot is on the edge. It has to go straight through. I don't know yet whether it turns there or there. This is another black dot that is close to the edge, so I know that it cannot go right because it would go off. So I know that it has to go left. This dot is now not a white dot, because if it were a white dot, I will show you, it goes straight through. It has not turned to the south, so it has to turn to the north, and in which case, if it does that, it would run right into this black dot, which cannot be true. So this gray dot is a black dot, which means it extends left. Now this black dot is forced to go up, so its shape is completely set now. And now I can look at this this gray dot. And actually these collection, both of these gray dots in conjunction with these two white dots. So this is another configuration that is somewhat common in Masyu. Whenever you have a black with a white, kind of diagonally like this, you cannot have a black dot that kind of engulfs the white dot, because the problem is the white dot, remember, has to go straight through. So either way it does that, it's going to cause a branching of the loop. So if this is a black dot, this configuration is not allowed. And so if it were black, it would have to be this, in which case I've got a mini loop. So that tells me that this gray dot is in fact white, and that is going to allow me to start shading some of the loop polarity. And actually, I know that this dot is also white, because either way, if it's black, it's going to engulf the white dot, kind of like I just showed you. So I either have to go straight through or straight through. Neither of those is possible. So I also know that this gray dot is also white. And that's super powerful, because neither of these white dots have now turned, and they've now met in the middle. So they have to turn up like this. I've hit this white dot, so I have to extend. This loop end can now not turn there or there, because it would cause branching. So it has to turn there. And now I can do a whole bunch of shading. So I know these are inside, that is outside, 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 inside. All these are inside. And now for my white dot here, I've got these two that are inside the loop, so these two have to be outside the loop. Likewise, this white dot has two outside the loop, so these have to be inside the loop. I cannot also have a checkerboard, so I can't have this, because that would cause a loop branching. So I know that that is also green. I've got a ton of stuff that I can sketch in, and I now have my first region. So remember, I have to do some star battling too. So I know that there's a star somewhere in here. Now this white dot has not turned. Actually, let's take care of this. So I know the loop comes along this side. This is indeed a black dot, which I knew before, but I now know that it has to go up. So now this loop end cannot run into the black dot. It has to turn like this, which allows me to green these, gray that, gray that. And now this, I'm going to come back to this point. So this gray dot can now not be white, because if it were white, it would go like this, and it would have to turn. But in doing so, these two would be inside the loop, and I'd have two insides of the loop across a border, which that can't be true. So this gray dot is in fact a black dot. And now I can say the same thing I did before, which this black dot now has extended to the right. It cannot extend down, or else I'm going to strand this poor little dot down there. So I know that this one goes up. And now at this point, you have to make my signature deduction of the puzzle, if you will. So after the first little Masyu part, you kind of can get stuck at this point. Oh, let's fill in everything we can before moving on. This is black because it's got gray there, so it can't be white, because white would have to be horizontal. So green, 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 and that looks good. Now the point is you have to count the number of regions. So the rules of the puzzle say the Masyu loop divides the grid into regions, and every region. So you also cannot, all these gray regions there has to be 9 of them is the point, because there's 10 rows, 10 columns. So because there's 1 star in every row and column, exactly, there has to be 10 regions. And the inside of the loop I know is 1 region. So there has to be 9 outside regions. And if I count them, let's start here. This would be number 1. This would be number 2. This would be number 3. One of these is number 4. I don't know which yet. This would be number 5, number 6, number 7, and number 8. So the problem is I need 2 more outside regions. And how can I possibly fit them into the puzzle now? Unless they go there and there. So I also know that this, for example, cannot now reach whichever side of this is exterior. This and this are both outside regions. And I can't have this cell being gray, because that's going to merge these 2 outside regions into one. So I have to do something like that. The loop, which I'm going to draw in a second, has to get out, and that is super powerful, because this dot now has become black. I can draw my first star into the grid, and once I have 1 star, I can X out the rest of the cells in the row and column, and I can do the one diagonal because stars cannot touch. This region star is somewhere in row 2, meaning this cannot be a star, otherwise I wouldn't be able to put a star there. So this region has to extend. This region also has to extend, but it cannot bump into this region, so this green has to get out, and 1 more actually as well. So I can also green this, and I can draw in some of my edges. This black dot has to go down because it can't go up, and it also cannot go left now, so it has to go right, so I can draw all that in. Let me do my star battle so I don't forget. The rest of row 3 and column 2 is out of bounds now, as are those 2 cells. And also I can X out these 2 because I know my star is somewhere in row 2 in this region. Now I can say this black dot now cannot go up, so it has to go down, and that allows me to shade in some more of my loop. This is green, so that's gray, this is green. This region still hasn't gotten its star, so it has to come out by 1 more. This white dot now has 2 greens on its left side, so it has to have 2 grays on its right side, and it has to extend like that. Remember what I was saying earlier at the start, that this green region has to connect to the rest of the greens in the puzzle, so it has to come out like this. I cannot have a checkerboard, so this also has to be green. So I draw in all these edges, and another one of my regions is now finished, so I can mark this as a star, and get rid of all those cells as being potential places for stars. This cannot be a checkerboard, so it is green. And now is another minor sticking point of the puzzle. So now at this point, what I have to recognize is I have to get this lower right region a star. So where can I possibly have this region getting a star? So row 10 is an option, right? It could be in this cell or in this cell. But if this star is not in this region, where is it going to get its star from is the question that I wanted you to ask. So remember, if I go up, this outside region can now not bump into the outside region that is across these 2. So this would tell me that this outside region would have to be on this side, which is fine. So this would be an inside. This would all be outside. The problem is now that the gray, remember in this world, I'm slightly looking ahead to see that the star for this region is not in this row. So it has to come out to here, but it can't go any more because this white dot would have to close, and that would be it for this region. So the point is, for this lower right-hand region, my star is somewhere in row 10. And that means that this cell is out of bounds for the star battle. And this means that this region now has not gotten a star, so it has to extend up. I can't have a checkerboard now, so this edge can be drawn in. And that allows me to say that, and it allows me to say that this black dot extends this way. It also allows me to say that this black dot can now not extend up, because now I would have inside and outside on both parts of the loop. So this black dot extends downward. Now I can shade in some more stuff. This green part on the left side has to get out, so it has to escape through there. I've now got another star battle region complete, but it doesn't have a star, so I know that has to be the last star. Whoops. Okay. This region still hasn't gotten its star yet. Or actually, this green, right, has to get out somehow. So the only way that this green can get out, because it's in danger of being trapped if it doesn't come through this channel. So that helps me to establish the inside-outsidedness of the loop here. This green has to get out. This gray still hasn't gotten its star, so it comes here. This white dot has 2 grays there, so it must have 2 greens there. And I can draw in some other edges. This is going to force the loop to bend, which is good. Remember, the loop has to bend on one side of white dots. And now by connectivity, I know that my inside of the loop has to extend through there. And that is going to force some of this. This white dot has to be satisfied. These 2 have to be outside the loop, so I have to do something like this. I can't have a checkerboard, so that becomes outside, this becomes inside. And now the Masyu is finished, and the only thing left to do is finish the star battle. So that's the only place for a star in this region. That's the only place for a star in this region, which disqualifies all the rest of the column 9 cells. So this is a star, and now in this region, these cells are disqualified, so this is a star. And now, let me X out so it's a little bit clearer. My green region still needs a star, my great big green region there. So now that everything else is out, this is the only place for a star in the green region. And now this is out, this is out, this is out, and that is the place of my last star. And that is the solution to the puzzle. I hope this solution path has shed some light on what I was intending. And just to explain the title, Starmie, when I was younger I used to play Pokemon, and Starmie is quite literally a battling starfish Pokemon. And it has 10 points, which I thought was a cheesy allusion to the 10 regions and the 10 stars that are in this puzzle. All right, once again, hope you enjoyed. Bye for now.